Okay, first of all, polynomials, okay? Polynomials. What they are is polynomials have, more than anything, they have whole number exponents. The term poly means many, like many terms. But more specifically, it's many terms where all of the exponents have to be whole numbers. Whole numbers are the numbers 0, 1, 2, 3, ... okay? Whole numbers are not fractions. Whole numbers are not negatives. Whole numbers are not decimals. Whole numbers are just simply 0, 1, 2, 3. So if I look at all my examples, A through F, these are polynomials, okay? Why do we study polynomials? Because they are curvy. They curve up and down. So A, if I look at A, it corresponds to this graph right here. A actually corresponds to graph A. Do you see how it curves up and then down? Okay, what we see about it also is it has as many as 1, 2, 3 zeros. And we talked about this last year, or last semester in geometry. X squared, how many answers? X cubed, how many answers? 3. 1, 2, 3 answers, okay? X to the fourth. Take a look at F. F corresponds to this F, all right? Nope, I'm wrong. F corresponds to... there you go, C. F corresponds to C, all right? And you see it's curvy again, right? So with polynomials, and this is just an introduction to polynomials, the higher the degree, the more it can curve. Does that make sense? Can curve, all right? All right, so the degree. The degree is always the highest exponent. In A, the degree is 3. In B, what's the degree? What's the degree in 3? In B? 3. What's the degree in C?
4.
Yep, it's that easy. It's just the highest exponent, okay? And by knowing the degree, we'll always know how many answers. Degree 4, 4 answers. Degree 3, 3 answers, okay? Degree 5, 5 answers, so forth and so on, okay? Some of the answers are real and some of the answers are imaginary. Remember that from last semester? So we can get imaginary answers. That whole thing about I, right? Okay? All right, now, turn the page to page 63. Okay, everybody go to page 63. Okay, everybody on page 63. Now, standard form. Standard form, we talked about this last semester, is biggest exponent all the way down to smallest exponent. This is super easy, okay? So if I take a look at number 1, first of all, is number 1 a polynomial? Yeah, whole number exponents. Whole number exponents. This is a little 1, whole number exponents. Invisible 1. And check this out. This is an x to the 0 power. That'd be silly to write that, though. You guys agree? Right? But it is a whole number exponent. I've got a 2, a 4, a 1, invisible 1, and an x to the 0, invisible 0. So, but it's not in order. To put it in order, biggest exponent first. So let's rewrite. F of x is equal to negative 3x to the 4th plus 2x squared plus 6x plus 1. That is in standard form, okay? Degree, 4. You guys agree? Degree 4. Leading coefficient is the negative 3. The leading coefficient is the number in the front after you rewrite it. The leading coefficient is the number in the front after you rewrite it. So my leading coefficient is my negative 3, okay? Easy? Right from biggest to smallest. Degree is the biggest exponent. Leading coefficient is the number that leads the charge, okay? How about 2? Is 2 a polynomial? It's not. Why do you say no? You're correct. Why do you say no? This is 7x to the negative 1. If you brought up the x, remember that from geometry? No? Okay, if you bring it up, it's a negative exponent, so this is no because you don't, that's not a whole number exponent. All right, let's move on. Okay, evaluate the function. 5, h of x equals negative x cubed minus 2x squared minus 3x plus 4, x equals 2. What are you going to do with the 2?
Plug it in.
Plug it in. H of 2 equals negative 2 cubed minus 2 times 2 squared minus 3 times 2 plus 4. Please, 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 please just use a calculator, okay? Maybe you're super genius, but I make mistakes, don't I? So I'm just going to truly put it in just like this. Watch me do it in my calculator. Let it do the work. Negative parentheses 2 to the third power minus 2 times 2 squared minus 3 times 2 plus 4. Let the calculator do the work, right? Boom, I got an answer of negative 18, which there's a point 2, negative 18 on my curve, right? Does that make sense? We know it's this funny little curvy curve, right? If I plug in 2, which is an x value, I get a negative 18 as my y value. Okay. All right. 7. End behavior. Okay. End behavior. What's my leading coefficient? Yes, yes, yes. My leading coefficient is negative 3. So you know what's going to happen? At the very end, it's going to take a dive because it's negative. At the very end, it's going to whoosh, whoosh, whoosh. At the very end, here, I'll do it from your perspective. It's going to curve, it's going to curve. At the very end, it's going to take a dive because of the negative leading coefficient. Okay? So it talks about end behavior. So end behavior is as x approaches infinity. So as x values get bigger and bigger and bigger, as x approaches infinity, my y will approach negative infinity. It takes a dive. Does that make sense? As x gets bigger and bigger and bigger, x gets bigger and bigger and bigger, then at the very end, y is going to go down to negative infinity. Yeah, Daisy?
How can you approach infinity when it goes off the route?
Great question. Oh my gosh, that's a calculus question. Super cool. You're totally right. So that's why we say approaches infinity, because you're right. I never said x equals infinity. Such a good answer. You ready? Here's what she said. How can you approach infinity when it goes on forever? You can't get to infinity, can you? So we say we approach infinity because you can't get there. That's why we use the term approach. That was really well done. Okay, how about 8? What's going to happen on end behavior? How about 8? First of all, what's my leading coefficient on 8?
Positive 3.
Yes, it's positive 3. Everybody agree?
Because it has the highest degree.
Yes, totally right. So this one in the very end is going to take off to positive. It's going to go loopy, loopy, loopy. At the very end, it's going to go off to infinity and beyond.
But there's a fraction in it.
It doesn't matter because if the biggest, like you said, if the biggest degree
Oh,
is positive,
it's not.
and so even if there were a fraction, it would approach infinity maybe a little bit more slowly. Are you with me? But it's still going to head off to infinity, okay? So this one, as x approaches infinity, okay, as x gets bigger and bigger and bigger, y will approach infinity, okay? Okay. One last thing, okay? Look at 9.
It's going to be negative.
One last thing. One last thing.
It's not Mr. Davis.
So as x is approaching infinity, right? What's y approaching in this one? Negative infinity. Good. Okay, does that make sense? But what about on the back? As x is approaching negative infinity. Okay, now this is a little bit tricky, but I know you can get it. Think about the x values, not the y's. But as x is going this way, watch my hands. As x is moving this way, what's the y doing?
Going up.
It's going up. Okay. Y is approaching positive infinity. Now, odd and even functions. Hey, now, watch me do it. Odd functions. Watch. Or, this next cube, this side's going up to infinity, the other side's got to go down because it's odd. Does that make sense? Right? Does that make sense? This one's an odd function, right? Copy next cube, okay? Even functions. Or, even functions. What happens on the end behavior? So an even function, if at the end it goes to positive infinity on this side, it's going to go to positive infinity on this side. If an even function goes down to negative infinity, then at the end the other side goes down to negative infinity. Got it?
Oh, when I was in geometry and we were working on making graphs, and I was telling Mr. Ford that I observed that when it's a negative, I mean not a negative,
Odd?
odd,
Yes.
it goes,
It's going to go just the opposite. So